All right, so today we're going to talk about linear and angular speed and how to do it, basically. So, what linear speed is how fast a position along the circumference is changing. So, if you picture a circle, you're looking at this point and how fast it's going around and around and around. Just that point is what you're watching. That's linear speed. Angular speed is how fast the central angle is changing. So if you think about, in my head, I think about a clock. Like, let's say this angle is changing. So this is shaded, and how fast is it shading like this? That's angular speed versus linear speed. You may remember from classes in the past that the formula for distance, not like the coordinate formula, but that distance equals the rate of change times the time. And that would be the same as the speed times the time, right? And for our intents, speed is constant. All right, so for us to do linear speed, so again, that's the speed of that point going around the circle, around the circle, is v equals s over t. The v is speed. What was x? Or not x, s, do you remember? Arc length. And the t is time. All right, and it may be helpful to write down the formula for arc length that we used the other day, the radius times the measure of the degree in radians. So this is the formula for linear speed. The problem with these problems isn't so much the formula, but the conversion and how to get to the point that we're ready to use the formula. Some other things you might want to remember is that one rotation around a circle covers a circumference of 2 pi r and has 2 pi radians. And you can picture that when you picture our little, coordinate plane. And if we went all the way around, the angle would be 2 pi. All right. So that's what you have to think about. Remember this because we're going to use it. All right. So for this problem, we want to find the linear speed in meters per second. So we're going to use our formula. It tells us how many revolutions it makes per minute. So for our work here, we're going to be going with a minute for our time. We don't know the velocity, the speed, and we need to find the arc length. So let's go over here. Arc length is the radius times the measure in radians. The radius is not 56, that's the diameter. So from that, we're going to get that the radius is 28. 56 divided by 2. That's the radius. And it makes 430 revolutions. Each revolution is 2 pi. So 56 pi is 1 revolution, the arc length of 1 revolution. So let's write that down. But how many revolutions do we have? In this case, we have 430 revolutions. So we're going to multiply that times 430. I like to leave mine in terms of pi. 56 times 430, 24080 pi. I like to leave it in this form until I get to the very end when I actually multiply by pi. All right, so we have enough information here. The arc length now is 24,080 times pi millimeters. Now, here's where people tend to get caught up. We need to change this. We need to look very carefully and see what it wants. And it wants meters per second. So we need to convert to meters per second. In order to do that, we need to make little other fractions to cancel. So we have minutes in the denominator. So I'm going to put minutes in the numerator to cancel. Each minute has 60 seconds. So you can see those minutes will cancel the unit, and we're left with seconds in the denominator, which is what we wanted. So we're good there. Now we need to change millimeters to meters. Since millimeters is in the numerator, I'm going to put millimeters down there. We need 1 meter is 1,000 millimeters. So our millimeters will cancel, and you can see we have meters per second. So now we're going to multiply through. In the numerator, 24,080 pi meters. In the denominator, 60,000 seconds. And all we're going to do is type that in now. 24,080 times pi divided by 60,000. 1.26 meters per second is our speed. Okay, again, I would pause, make sure you have everything written down, and then go back and listen again, because the hardest part is kind of keeping track. And if you're writing while you're listening, you're going to end up not really hearing. So go back and watch that part again if you feel a little bit confused. And of course, all the problems have variations to them, but it's all pretty much the same process. All right, let's do one angular speed. All right, we have a record with a diameter of 12 inches rotating at 33 rotations per minute. What we want to find is the angular speed in radians per second. And you know, it would help if I actually gave you that formula. Angular speed. That means angular speed, the measure in radians over time. So pretty similar. Speed, angle in radians, time. All right, so again, let's think about the things that we need. Well, let's write our formula. Okay, we have times rotations per minute. So for ours, we're going to have a minute on the denominator. And we need to find the measure or the degree in radians. So we're going to do that over here, the measure in radians. Each rotation is 2 pi. And we have 33 rotations. So 66 pi revolutions, or 66 pi is your measure in radians. So we're going to go ahead and put 66 pi over here. Okay. We need, this is radians, we need radians per second. Well, right now we have radians per minute. So the only thing we need to convert is the seconds. Again, since minima or minute was in the denominator, going to put it in the numerator so they cancel, and each minute is 60 seconds. The minutes will cancel, so we have 66 pi over 60 radians per second. And then we're going to type it in and simplify. So the angular speed is 3.5 radians per second. All right, so that's the process. Of course, you could be looking for any variable. You could be looking for any part, and you might need to make manipulations throughout. These are something you need to practice to get good at. It's not the kind of thing that you're like, oh, I got it, because each problem is worded a little bit differently. All right, see you later.